The data center went down on a Thursday. Not a cyber attack, not a fiber cut, not DNS gone rogue. A brand new rack of servers someone had plugged in. Nobody checked whether the circuits could handle the power draw. Nobody talked to facilities. Nobody thought to, because facilities was that team, right? The one you passed in the hallway, the one whose job you couldn't quite explain. IT owns infrastructure stuff. Facilities owns building stuff. Two separate worlds until they collided. And that's not a cautionary tale from a decade ago. This happened to a worldwide technology customer last year. During what should have been a routine infrastructure refresh, because they had budget, they had timeline, they even had stakeholder alignment. They had everything they needed. Everything except the one thing that sinks more refresh projects than anything else: visibility.
WWT Presents Research.
I'm Rob Boyd, and this is Worldwide Technology Presents Research. This is the first episode of the Data Center Priority Series, 4 conversations, 4 priorities, each one building on what comes before. And we're starting with infrastructure refresh because it's priority 1, but also because everything else in this series depends on it. Here's what the research makes clear. Refresh starts with visibility, not procurement. You have to understand what's running, how it's connected, what it depends on, and what you don't know yet before you spend $1 on new equipment. Well, Eric DeLallo and Nathan Litz see what happens when organizations skip that step. Eric leads WWT's compute practice as principal solutions architect. Nathan is a technical solutions architect focused on data center networking. Between them, they've watched this same pattern play out repeatedly. Teams work in silos, infrastructure treated as isolated components, and refresh projects that become expensive surprises because nobody looked at the big picture first. Well, infrastructure refresh usually arrives as a pretty confident request. Eric, when he hears something more complicated.
Sometimes we're engaged by maybe the compute team, and the compute team, doesn't have a broad view of the network and the storage and the virtualization and the all of the different pieces of their own environment because either they're so big and there's a lot of islands and that, will create some visibility gaps. And we kind of want to see the whole thing when we come in. So, we need a refresh of our compute infrastructure. Is a very loaded question.
Compute connects to storage. Storage connects to networking. All of it connects to power and cooling. Pull on one thread, you're going to find dependencies that nobody documented. Applications nobody remembers deploying, constraints, really, that never appeared in any spreadsheet.
I'd say, honestly, in my immediate experience, I'm usually brought in for a more kind of focused refresh. So focusing on data center networking, but as part of, the working with our customers and working through these workshops with them, I like to broaden the conversation. I'm with the network team, I'm with the network team decision makers, and we're here to discuss, switches and routers and all that kind of fun stuff. But ultimately, we need to have a cadence with the storage team, and we need to have a cadence with the compute team, because ultimately their needs, if you approach your colleagues as customers to some extent, especially if you're on the network team, we need to be able to meet their needs.
Approach your colleagues as customers. The network team isn't buying switches for themselves. They're building connectivity infrastructure for every other team's requirements.
I started asking a few questions because a lot of the switches that they were looking at, they had done their own research and a great job of it, were maxed out at 25 gig connectivity. And, I kind of would pose the question, what kind of things, a really high level, simple question, what plugs into your switches? What kind of storage arrays do you guys have? What kind of compute servers do you have? And there was not a ton of visibility to that. I kind of challenged them to say, between today's meeting and the next meeting, I would encourage you to speak with and work with your counterparts on the sysadmin side of things, and understand what their servers need, or frankly, do their servers today have higher bandwidth connectivity capabilities, but they don't use them because the switches aren't there today?
The network team went back and had that conversation. In fact, a week later, they returned with an answer.
Their compute team was in the midst of beginning a refresh cycle, and all the new servers that they were looking at had not just the 25 gig connectivity that the network team was immediately scoping for, but the compute team was actively attempting to move to standardize their connectivity at 100 gig.
25 gig versus 100 gig. Not a minor spec difference. That's a complete re-evaluation of which switches you're buying, what your architecture looks like, and how much budget you actually need. Two teams inside the same organization were running parallel refresh cycles with no one talking to each other.
If we are able to get the customer to have that broader conversation at the very beginning, it actually makes the more focused conversation down the line, be it network, be it compute, that much more focused, right? Yeah. If we start broad and we say, okay, what are the connectivity needs of the storage team, of this team, that team, when we get down to the point where we're discussing network hardware specifically, if we now know through that broader conversation we need 100 gig connectivity, we're not going to waste time having a conversation around 25 gig connectivity.
Start broad, end focused. Discovery eliminates the wasted effort on the wrong solutions. The visibility problem doesn't stop at team silos.
There's legacy applications that maybe, there's been high turnover, and these legacy applications have just been running forever. And we don't know what we don't know on them. So it's our job to help them go figure that out. And we can use various tools to kind of figure out what those are doing and what they're mapped to. So application mapping kind of becomes, kind of a topic at hand, which again is another practice. So we drag another practice in to kind of map out some of these applications, figure out what they're doing, figure out, can they be modernized? Can they be taken down or offline, or can they be, totally taken out?
Modernized, taken offline, or removed entirely. 3 fundamentally different outcomes, each with different implications for your refresh strategy. You can't answer that question if you don't know the applications exist. And that's exactly what Eric means when he says refresh is never just a compute refresh.
It's never just a compute refresh. Compute sits kind of in the middle of all of this, functioning infrastructure. And, it's our job to turn, if there is chaos, turn it into something that's, manageable and understandable.
Servers connect to storage arrays. Storage connects to network switches. All of it connects to power distribution and cooling systems. Change one component and you create a ripple effect everywhere else.
We've had a customer, plug in a rack full of modern compute and pop some circuits, and their data center went down because facilities was not considered.
The data center went down, not from an attack. It's because nobody checked whether the electrical infrastructure could handle the power draw of modern servers. That's what the research means by holistic modernization. Infrastructure components aren't independent variables. They're a system, and the system has constraints that only become visible when you map dependencies across teams. In networking, there's a concept called layer 0. It's power and cooling, the physical infrastructure that sits below even the network cabling layer. Even without AI workloads, that layer is under more pressure than it's ever been.
Layer 0 is more important than it ever has been in the past, right? The power, the cooling, the facilities aspects of a data center. Even if we're not discussing AI specifically, just modern networking, everything is denser from a heat and energy perspective. It's requiring more power. Anything from 15 to 20 kilowatts per rack is common nowadays, and 5 years ago it wasn't.
15 to 20 kilowatts per rack used to be an edge case. Now it's standard for enterprise workloads. That changes every refresh decision: which servers you select, how you lay out the racks, whether your cooling system can handle the thermal load. But it's also changed who you need to know.
Something that early on in my career was never really on my radar was power and cooling, but that was always just something that got handled by a team that really a lot of the internal teams in IT didn't really have access to. It was always that, a person that you kind of knew who it was because you saw them around the facility, but never really had a relationship with that person. Well, now's the time to have that relationship with that person.
The person who manages facilities and power distribution isn't a peripheral player anymore. They're central to whether your refresh project succeeds or fails. Infrastructure refresh requires visibility, not just across IT teams, but across the entire stack, from application owners down to the people managing electrical panels and HVAC systems. Once you have that visibility, the next challenge is making decisions without letting bias drive them. WWT uses a structured methodology called the market scan to document business drivers, operational constraints, and risk tolerance before any vendor conversation happens.
I like to mask OEMs on the market scan. It's a very in-depth spreadsheet. I like to make it look as we're just having business driving conversations with the IT stakeholders.
Yeah.
We kind of will plot out what they deem important, what they deem high risk or no risk, and we go through everything. So most of our customers, they do buy within the big OEMs that we sell, Cisco, Dell, HPE. We do have other compute vendors on here as well, just to make sure, that we're making sure that everything is thought of. But ultimately, we give a top level score, and that score kind of defines what features they're looking for, what risks they're either willing to accept or not accept, their risk tolerance, their operational constraints, but ultimately it comes down to, an OEM or a few OEMs.
Hide the vendor names. Avoid the potential bias. Bad experiences, preferred interfaces, those long-standing relationships. The market scan removes these before helping you shape that decision.
So having that empirical data that they and their team have gone through alongside us as, industry experts to help them guide through those decisions, to when they go to the decision makers at their business to say, why are we doing this? Why are we making this purchase? We've always done it this way. Why are we continuing to do it that way? Or why are we now doing it this way? So to have the actual rationales behind that that the market scan is what provides that capability. And when you start that market scan kind of process by masking the OEMs, you're essentially removing implicit bias, which makes that empirical justification that much stronger at the end.
When your recommendation is grounded in documented requirements rather than vendor relationships, you build credibility for whatever recommendation emerges.
At the end of the day, it's a receipt. It's a, historical, how did we get here? Which,
Exactly.
2 years in might become pretty valuable of why we made that decision.
2 years from now, when leadership changes or budgets get challenged and someone questions why you chose a particular architecture, you're not relying on institutional memory. You have documented evidence of the business drivers, the constraints, and the trade-offs that led to that decision. The market scan creates the criteria for a good decision. The next step is validating that the solution actually works in your environment before you commit. That's what WWT's Advanced Technology Center is built for.
When I first started, I'm not going to say it was small, but it was a single data center. And to effectively have quintupled in size in roughly 10 years, it's unbelievable. The capabilities of the data center, we have the ability to almost without fail replicate exactly what the customer is looking for, whether it's from a software use case, whether it is from a hardware use case. They want to see this particular storage array and this particular tier of networking and this particular tier of compute. That can be replicated in real time in the data centers.
Real hardware, real configuration, real workloads. That's the difference between trusting a vendor's claims about interoperability and actually knowing before you spend millions.
We're not just, running through PowerPoints and slides and theoreticals. We're taking that product and we're plugging it into this other product and we're configuring it. We're showing them how it works. We're running tests on it. We're giving them that data in real time. And even so, letting the customer, have the keys as much as they may require to go vet it themselves as well. Even if, hey, we're not doing any AI. We certainly want to make sure we cross that T and dot that I, make sure that we're ready for it when the time comes.
You're not trusting vendor claims about performance. You're validating them in a controlled environment that mirrors your production infrastructure before you commit enterprise-wide. And those same validated decisions inform how you think about what comes next. Every infrastructure refresh conversation right now runs into AI. Even organizations with no current AI initiatives, well, they're feeling the pressure. And the answer isn't to build everything for AI today. It's to make strategic investments in specific parts of your architecture that create the headroom without requiring you to overbuild everything.
When we're looking at a data center network refresh from a hardware standpoint, regardless of what OEM, generally speaking, from a physical standpoint, we're looking at spine leaf. So it's going to be a spine leaf setup from a network perspective. And ultimately your workloads, your storage, et cetera, is going to connect to the leaf, right? Your compute leaves. And if we don't necessarily need compute leaves that are going to support, 4 or 800 gig or the next gen of 1.6T, that we're seeing here shortly, fine, not a problem. You don't have those needs. You don't forecast those immediate needs, not a problem. I would strongly encourage a customer, though, to assess the financial burden, or hopefully lack thereof, to have their spines in a spine leaf scenario be supportive of 4 and 800 gig.
Don't overbuild at the edge where workloads actually connect, but invest in higher capacity core infrastructure, the spine that can handle future bandwidth demands without requiring a complete architectural redesign.
That way, even if you have standard workloads that, let's say you have a particular rack that is highly dense from a compute perspective, and you need those higher bandwidth connections, having a higher bandwidth spine is going to allow you to scale properly. Or let's say next year, there is an unforecasted need for AI supportive infrastructure. You may be in a position where you need to replace a top of rack leaf, but you've made the decision ahead of time to future-proof as much as you can your infrastructure from a spine perspective, so that you can plug in that 400, 800, 1.6T leaf and have the spine capability to support that bandwidth to bring that into the rest of the fabric.
Replace a leaf switch versus redesign your entire core network architecture. That's the difference between tactical adaptation and strategic disruption. That same logic applies to compute.
The compute that we sell them, can they handle GPUs? Do they have the right amount of airflow, power and cooling to the rack? So all that stuff, we want to answer above and beyond and document it so they can go back should that need arise, which, we're very optimistic that need will arise. And so kind of do that pre-work ahead of time. So that answer becomes a yes. And here's how you do it, because we future-proofed your environment. So those racks or those blades, they'll take, these GPUs, and looks like these racks have enough power, energy to them, and, they're cooled efficiently.
You're not installing GPUs you don't need today. You're verifying that your power distribution, airflow, and chassis can accommodate them when requirements change, and you're documenting that before anyone even has to ask. This matters, even if AI never enters your roadmap. Modern equipment is denser than what it replaces. More watts per server, more heat per storage array, more electricity per switch. The layer zero considerations that Nathan described apply regardless of what's running in the rack.
Successful organizations, we like to see them curious and not rushed. The latter there definitely leaves a lot of room for error.
Let's go back to that rack of servers. I think it was on a Thursday. See, that organization had budget, they had timeline, and stakeholder alignment. What they didn't have was visibility across domains, or perhaps the curiosity to ask what they didn't know. Eric and Nathan see variations of this constantly. The network team scoping 25 gig switches while compute standardizes on 100 gig. The legacy applications nobody documented. The facilities engineer who's always there but never included in the planning. The work they described, the cross-team conversations and the masked market scan, the validation in WWT's Advanced Technology Center before you commit. That's not process overhead. That's the receipt. 2 years from now, when someone questions your architecture decisions, you're not relying on memory. You have documented business drivers, validated performance data, and strategic investments in the spine that created headroom without overbuilding everything. The Data Center Priorities Research from WWT, it can be found at WWT.com, and it walks through all 8 steps from comprehensive assessment through phased modernization and makes the case for why foundation work eliminates the expensive surprises. Private cloud, AI-ready infrastructure, cyber recovery. These are the next 3 conversations in this series, and each one assumes you can see what you're building on. Successful organizations, according to Eric, they're curious and they're not rushed. This is what building that foundation looks like. I'm Rob Boyd. Thanks for watching.
This episode is supported by Nokia. Nokia helps you realize your digital potential with trusted purpose-built IP, optical, fixed, and data center solutions, providing superior performance, security, and seamlessly integrating into any ecosystem. Nokia, pioneering networks that sense, think, and act.